Cool, thank you so much. Thank you. Yeah, so I'm Harry. I'm here this evening to talk about site speed, but a very, very specific subset of site speed. I want to talk about something called largest contentful paint. Now, largest contentful paint is one of three relatively new web performance metrics coined by Google as part of their Core Web Vitals initiative. And over the next sort of 30 minutes, we're going to be learning all about what it is, what it means, what its implications are, but most importantly, how to do a good job. So I'm going to show you how to optimize this metric. Now, as Stanislava just said, this is my third time here in Novi Sad, third time at DAFED, sorry. Probably my sixth or seventh time here in Serbia, and every time I come back, I get treated so kindly, I make a bunch of new friends, it's always great to see old friends, and I'm always made, more than anywhere else in the world, I'm just made to feel very, very at home, very, very welcome. And I think this trip in particular is the best example of that, because whoever organized British weather for me earlier, I don't know how you managed that, but I felt so at home. It was just like being back in England. But no, 8 years ago was my first time at DAFED, 8 years, which makes me feel very old, but it's great to be back, so thank you for having me. One thing I did realize is potentially, especially some of the diagrams on my slides, may be a little small on this screen. So if you want to follow along from in the audience, the slides are already online. So if you just want to dive into that URL, you can get the slides on your phone in front of you. But with that said, I'm just going to press ahead. We've got a lot of slides in this talk. It's going to be a relatively technical talk. I'm not a very inspiring or inspirational person, so it is going to be fairly literal, fairly technical. But my day-to-day work is as a consultant. I work with generally fairly large organizations to help them find and fix site speed issues. Generally, companies of this size will feel the benefits of web performance more than others. Generally, the issues and their solutions tend to present themselves at scale. But ever since Google announced their intent to consider site speed in their ranking algorithm, a lot more companies have been getting in touch with me, a lot smaller and a lot more diverse type of organizations. This isn't going to be an SEO talk, but largest contentful paint is part of getting a good ranking nowadays, so it's more important than ever to be fast. So LCP, largest contentful paint, I mentioned before, is a relatively new web performance metric, and it was coined by Google along with two other metrics. You may have been used to using things like load times or even DOM content loaded or metrics like that to measure site speed in the past. The problem is these are all fairly crude proxies for how fast a website actually is, and certainly how fast a website feels. So largest contentful paint was a metric that's designed to be user-centric. When was the biggest single piece of content rendered to screen? It's not the best metric ever, because largest doesn't necessarily mean most important, but it's a fairly good proxy, it's a fairly good implication. So what we're looking for is when was the single biggest bit of content painted to screen. This slide is not meant to be in there, so ignore that, pretend you didn't see that. This one's the one I'm after. It turns out on the DAFED site, it's actually this paragraph that Google or Chrome would consider to be the largest piece of content on screen. What's quite interesting about this example is Google, or the Core Web Vitals team, have very strict definitions for what they would consider the largest piece of content. You'll notice the DAFED website has a full-size background image. What Chrome will not do is it will not consider full-size backgrounds as content. So that means we get a much better score here because we're not relying on waiting for an image to render, we're just waiting for this text to render, and text is generally going to be faster than images. On the flip side, on my site, this isn't a full screen background image. This background image just occupies the header. So Google will consider this image for largest contentful paint. It will consider background images. Interestingly, if you look at the meta.com site, what we'll find is this H1 is considered the largest piece of content. You'll see there's an image in the background that isn't full screen. We can see the header and the nav above it. It's not a full screen image, but this isn't getting considered for largest contentful paint. And that's because technically this isn't an image. This is the first video, or this is the first frame of a video. This is actually a video element. And Chrome will currently not include video in your largest contentful paint element. The importance here is that you get a choice of what element you could use, and there's only a finite list of what Chrome will consider. So even your choice of element will dictate how good or bad your score might be. So when we talk about scores being good and bad, Google, as well as defining the metrics, define the thresholds for good or bad. The reason I want to give this talk is LCP is probably the easiest of all the 3 new metrics to debug. It's the easiest one to monitor, it's the easiest one to fix, the easiest one to track, but it's the one that people struggle with the most. We'll see that only about 50%, or 55% now, of origins, which is just websites, actually have what we would consider a good largest contentful paint. And this really surprises me, because it's genuinely the easiest one to fix. So the whole point of this talk is trying to encourage people to get LCP fixed, get a lot faster. When we talk about good, as well as defining the metrics, they define the threshold. So Google said that a good largest contentful paint would be 2.5 seconds or faster. If you can get the biggest bit of content on screen in 2.5 seconds or faster, you get into this green zone. And if you're in the green zone, that is going to be good for not just user experience, it would also be good for SEO. They will take site speed into consideration when ranking your sites. So it's now kind of an important thing for SEO to be fast. I was interested in learning why 2.5 seconds. Like, why did they decide that? And there's a couple of things that went into it. The first thing is that there's quite a lot of user research that says that the human brain will start to disengage after a certain amount of seconds. It's normally about 3. They also found that 10% of websites at the time they defined the metric could get this 2.5 second threshold. At the time of defining the 3 performance metrics, they wanted to make sure that at least 10% of the web currently achieves it. It makes it quite aspirational. Only 10% of websites can do it, so it's kind of something to strive toward. But now, as we can see, that number is getting bigger and bigger. It's like nearer 50% now. So this is going to be a relatively technical talk. I just want to address the SEO thing one last time. Site speed is more than just SEO. A lot of my clients have been getting in touch with me purely for search engine optimization reasons. We want to get ranked highly, therefore we need to be fast. SEO is really important, but the thing to remember is SEO, it gets someone onto your website. It's their experience while they are there that dictates whether they will become a customer or not. So this is a case study from about 4 or 5 months ago now. Still using LCP, but not thinking about SEO whatsoever. I worked with a company in Sweden. Together we worked out that if we could improve their LCP by just 500 milliseconds, they would make an extra 11.5 million euro a year. So site speed is really, really big business, and it's way more important than just the SEO implications. So I would encourage you, especially if you're in e-com or retail, paying attention to metrics like this is going to be really good for business. Okay, so the whole point of the talk is how do we get to good? How do we achieve that mythical 2.5 seconds? Well, I've got a bunch of insights and tips for getting there, and the first one is solve everything beforehand. LCP is what's known as a milestone metric, and it's actually a metric at the very end of a load of other preceding steps that a web browser has to go through. Everything on screen right now is a potential step a browser would have to go to before it can even get to that largest contentful paint. DNS, network negotiation, right? TCP, TLS. Any redirects you might have, time to first byte, first paint, first contentful paint, all of these are preceding metrics. And if you're slow at any of these, you're really going to struggle to get a fast largest contentful paint. The 2 items with asterisks next to them, they are considered web vitals, but they are not core web vitals. There are 3 core web vitals, of which LCP is one of them. The other 2 are just web vitals that Google are tracking, but they are not using against you when ranking you. So if you've got any problems in any area currently on screen, you will really, really struggle to get a good LCP. An example of this, this is a client I'm about to start working with. You'll notice here their time to first byte is already 2 seconds. If you're losing 2 of your 2.5 second budget to the server, that is a really important place to start looking. What's interesting is that every step on the way, they get slower and slower and slower until they've completely overshot that budget. What I find particularly weird and annoying and interesting about this site is the reason there's a huge jump from 2 seconds to 3.6, right? That's way too big. That 1.6 second gap between time to first byte and first paint is way too big. That's because this is a fully client-rendered website. So the HTML lands and it's empty, and then it has to download a full JavaScript application which has to boot, hydrate, and create the app. So what's interesting there is it's an empty HTML file that took 2 seconds to build on the server. This site is bugged. So we lost 2 seconds to time to first byte just returning an empty HTML file. Their bottlenecks are not in the browser, their bottlenecks are somewhere on the server. So yeah, the first advice I've got is optimize everything beforehand, try and find any issues sort of starting at the back end, working forwards. If you're losing time there, you're going to continue losing time. The next tip is choose the best element, and this comes back to what I was discussing earlier with the DAFED site, with my site, with the meta.com site. There is a finite list of elements that could be considered for your largest contentful paint. Google or Chrome, they will only consider a certain number of elements. This slide is copied and pasted word for word from the web.dev website, and it really annoys me because they list these potential candidates. They're called candidates. They list these potential elements that could be considered for your largest contentful paint. What they fail to do is point out that some of these are inherently slower than others. They haven't listed them in any particular order, but the options are you could have an image element counted as your largest contentful paint. You could have an image element in an SVG, and this is different, hence the different spelling. They are significantly different things. You could have a video element poster image. So the video itself will not be considered. The first frame of a video will not be considered for a largest contentful paint. But if you use the poster attribute, then that image will. An element with a background image or any block level element with a text node inside it, which is why the DAFED site got a P, got a paragraph. The meta site got an H1. First and simplest bit of advice is we love text-based LCPs. If we can get our largest piece of content to be a string or a piece of text, that's guaranteed to be much faster than an image. Text is just faster than images. We know that. We take a look at my About page on my site. If you measure it on mobile, and this is the exact same page on the exact same network conditions, it's even the exact same image, because I'm lazy and I didn't bother implementing responsive images. The moment we just swap the viewport from mobile to desktop, the desktop screen, or the desktop version, the image becomes the largest piece of content. And what we'll find is that it gets about 560 milliseconds slower, just because the image is still the exact same size, it weighs the same, but text is just inherently faster than images. If we have a text-based LCP, in this example specifically, we're over half a second faster. So if you could just redesign your entire site to have no images, that would be really fast. That's not going to work. So what we need to look at is image-based alternatives and how to optimize those. As a brief aside, if you do have text-based LCPs, it's important to make sure you manage your custom fonts properly if you're using custom fonts. So make sure you're using the relevant font display. So yes, for the more practical use case that's going to affect way more of us, what about images? So we had 4 different image types listed as potential candidates. So what I did is I just created an experiment and tested each of the types of image. Really simple HTML file, but what I wanted to do is I wanted to try and trick the browser. What I did is I deliberately put a render blocking script in the head of the document. I did this for 2 reasons. One, I wanted to make sure the browser was busy running JavaScript to see what it would do with the image. Would it download the image in parallel? Would it focus just on the JavaScript? I also wanted to see what happened when there are 2 files in flight. Would the browser donate bandwidth to both files equally? Would it prioritize the JavaScript because it's in the head? Would it prioritize the image because it's the biggest bit of content? I just wanted to try and trip the browser up and see what happened. And then I did an example with each of the, or an experiment, sorry, with each of the potential candidates. The results were pretty interesting. In fact, before I show you the next graph, I've talked about this 2.5 second thing. What I did to make this experiment really obvious, to make the charts really clear what was going on, I purposefully forced that JavaScript file to delay for 2 seconds. So all the results I'm about to show you are way slower than 2.5 seconds because I forced the JavaScript to block for 2 seconds anyway, just to exaggerate the waterfalls. That will become more apparent shortly. I didn't want to tell you all this and then show you a load of charts that were all way over 2.5 seconds, because I'd look like a total idiot just doing that. We find the images, an image element, image tag, renders in about 1.3 seconds. Image in SVG, really fast, 2.6 seconds. The poster image, again, 3.1, almost identical to the image tag. And finally, background images, 4.4 seconds. I expected background images to be slow, just because of how CSS and background images work. What I didn't expect is image in SVG to be so fast, and I was fascinated to know why this is the case. No one's using image in SVG, by the way. Like, literally, no one's using it, but for some reason they consider it for largest contentful paint. When I say no one's using it, I really mean that. If you look at the HTTP archive, which crawls the entire web, So few people are using this, it doesn't even show up in the data. Less than 0.01% of people are using this. So I don't know why they decided to include it, but why is it faster? And if it is so much faster, shouldn't we all start using it? It seems like a really good performance win. Well, it turns out there's a bug in Chrome. When I looked at the data visually, and you look at all of the experiments, the red box, or the red border, is what Chrome believed to be the largest contentful paint. It turns out that Chrome completely missed the SVG entirely and thought the paragraph was the biggest bit of content. So there's a huge bug here, which, if you want to exploit this bug for the next few weeks, go and just refactor your sites to use image in SVG. This bug will get fixed, but in the meantime, image in SVG comes back way faster than it should. So yeah, that was the problem we had there. When I adjusted the data accordingly and took the actual image time, image in SVG slipped back to around 4 seconds. So it's kind of somewhere between image, poster, and background image. Now, this is where I fear that the slides may be a little bit small, so hopefully you can sort of at least see the patterns that are emerging. When you look at the waterfall charts for these, some really interesting patterns do begin to emerge. What we're hoping to see here is that purple bar, that's images. So all we're looking here is just looking at the purple. When we graph things this way, we'll see that image and poster, that image is the first item to be discovered. It was defined second in the HTML, but for some reason in this example, or these examples, the browser found the image first, despite being defined second. And it also managed to download the image in parallel with the JavaScript. This is very healthy, this is very fast. The browser's doing this automatically, so I'm kind of interested to know why. Conversely, if we look at the other two examples, we'll find the image discovered second. Does start to make a bit more sense, purely because the image was defined second, but the problem is it's not downloaded in parallel anymore. It's completely serialized. This is very unhealthy and very slow. The browser theoretically should be able to download both of these files at the same time. For some reason, it wasn't. What's interesting is I did expect to see this for background image. I did not expect to see this for image in SVG, and we'll work out what's going on shortly. But the first thing to say is image is good. And statistically, it's almost 50% of websites have an image as their largest contentful paint. So most websites do have this as their LCP. The good news is this is really, really fast inherently, and I'm going to show you some tips to make this even faster. The syntax for an image, very, very simple. We're probably all familiar with this syntax. That's all I passed into the browser. This is really nice. The browser can handle this very, very quickly. To pull that graph out again, image is discovered first, downloaded in parallel. Now, the reason the image was discovered first is because of a magical bit of browser internals called the preload scanner. The reason I wanted to inject some or put some JavaScript in the page is I wanted to see if that JavaScript would hide subsequent files from the browser. The reason image was discovered first, despite being defined second, is because of something called the preload scanner. This is genuinely one of the most elegant bit of browser internals I've ever heard of. And it's in every modern browser. You don't need to do anything to make use of it. It's just there, and it has been there since IE8. Can you believe that? Microsoft invented this. Although because it was Microsoft, they couldn't call it the preload scanner. They called it the speculative preparser, because that sounds way more enterprise. You can charge way more to your internal, like profit and loss for a speculative preparser. Everyone else just calls it the preload scanner. Basically, in the olden days, in IE7 and all other browsers that were around at that time, discovering resources was really labor intensive, it was very slow, and it was very inefficient. The browsers, all browsers back then, had one parser, and that parser had to do everything. It had to read the HTML, it had to find files in the HTML, it had to download the files in the HTML, it had to run the files, then it would move on to the next line of HTML and be like, oh, there's another file, and it would go back to the server. Very, 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 very slow process. Downloading was completely synchronous. The same parser that had to build the page also had to find and fetch the resources for that page. The preload scanner was simply invented to decouple downloading and execution. So while the main parser is building the HTML and putting the page together, the preload scanner just goes off and looks for files ahead of time, and it throws them into a queue. Visualizing it with a waterfall, it becomes really obvious just how much faster this made the web. This is the exact same page. I'm afraid this looks really washed out, but this is the exact same page. The top is without a preload scanner. The exact same HTML in a browser that does have a preload scanner. All 4 of those files are now downloaded completely in parallel. This is way, way, way faster. Now, as developers, we don't need to do anything to make use of the preload scanner. It's there, and it works automatically. However, what we can do, and what we very frequently do, is we end up hiding things from the preload scanner inadvertently. And that's exactly what happened with image in SVG. The syntax for image in SVG is, well, it's XML, so it's familiar, it's similar to HTML, but remember, it is technically XML, so we've got closing tags, we've got quote marks in there. This is significant, and I've got a theory. I think it's because this is XML and not HTML that explains why it's slower. The syntax is pretty simple, but this isn't HTML. You can embed it directly in an HTML document, but this is XML. That's what the waterfall looked like. So we've got the JavaScript file first and the image discovered second, which sort of makes sense. The image was defined second. What I can't work out is why on earth they weren't downloaded in parallel. The preload scanner should be able to find all the resources in the page and fetch them all at the same time. The reason it didn't is because images in SVG are hidden from the preload scanner. So as well as there being a bug in which image in SVG is measured incorrectly anyway, browsers can't handle it very elegantly. And I think my theory is, because it's a separate file type, it's like an XML document, the preload scanner was never designed to preload scan XML. I think it only reads HTML. That's a theory, I haven't had it confirmed yet. Statistically, we're very unlikely to be using this anyway, so it's not really anything for us to worry about. But interestingly, just be aware of this, image in SVG will always be slow. Until the preload scanner gets updated, which I think is highly unlikely, this is always going to be a bad idea. Poster is good. This really pleasantly surprised me. I honestly don't think I've ever written or used a poster attribute on a video ever in my professional career, or my unprofessional career. The syntax, really simple. It's just an attribute that you drop on a video tag. Interestingly, when the preload scanner was built or updated to incorporate video elements, they ensured that it was available to the preload scanner. That's really smart. Someone deliberately made sure the preload scanner can find poster attributes. This explains why we get the image discovered first, downloaded in parallel. Poster is good. It's a very pleasant surprise. I like to see this. There's a very interesting thing coming up, though. If you do have video-based LCPs, if you're building a site or you work on a site where you have a lot of video and it's likely to be the largest piece of content on the page, make sure you are using a poster image, because there's a bit of kind of interesting thing around the corner. There's a bug currently open. Currently, a video element with a poster image is what would be considered. The first frame of a video will not be, I'm not reading this word for word, by the way, I'm just sort of making it up. Currently, they will take the poster image, but they think, or someone thinks, I'll explain whose fault it is in a second. There is murmurings that a first frame of a video may be considered for LCP in future. Downloading an image is going to be much, much faster than downloading a video file. If you're building a site or working on a site where videos are your largest bit of content and you aren't using poster images, a future update to Core Web Vitals, you may see your LCP start getting way worse. Because remember the meta.com example, the H1 came back as the largest contentful paint? That's because the video didn't have a poster image. Because the video didn't have a poster image, it was ignored completely, you get a nice fast text paint. When they roll out this change, all of a sudden, it will be that first frame of the video that gets counted, and you can guarantee that a first frame of a video will be slower than an image, which will be slower than text. It's interesting. It's YouTube's fault that this is happening, by the way. YouTube were refactoring to make the site faster, and what they realized is if you link to an auto-playing video, right? If you upload a video to YouTube, you can select the poster image. You can upload a completely you don't need to use a frame from the video. You can upload a completely separate poster image, which is probably very different to the actual first frame of the video. What YouTube worked out is it's a really bad user experience if you go straight to an autoplaying video and it shows you a poster image and then immediately starts playing. That's why whenever you get linked to a video directly that autoplays, you just see a blank sort of screen and then the video plays automatically. So what YouTube did is they went to the Core Web Vitals team and said, oh, can you maybe update Core Web Vitals to take the first frame because we'd like to measure that. It's like, thanks, YouTube. You just made everyone's job so much worse just to make your metrics a little nicer to capture. So it's YouTube's fault. What they've requested is that we do start capturing the first frame of a video. It hasn't rolled out yet, but it seems like it's quite likely. So yeah, just make sure you're using poster images. Background image is bad. I knew this would be bad. I knew background image would be slow because of just how CSS works. It's not the developer's fault, it's just how browsers work. Browsers are very defensive. So what I did is I just took an inline style attribute on a div. I didn't create a third style, a separate style sheet, because that would have guaranteed have been slower. I put it straight in the HTML. And even though this is straight in the HTML, we get this behavior. The image is discovered second, and it's not downloaded in parallel. This image was hidden from the preload scanner. There are two reasons why this image was hidden from the preload scanner. The first reason is the preload scanner only scans HTML, and CSS embedded in HTML is still CSS, so the preload scanner can't read it. But there's another interesting reason why this was hidden from the preload scanner, and this is something that I find a lot of developers aren't aware of, but once you kind of learn it, it completely changes how you view CSS, background images, and actually web fonts. So background images are hidden from the preload scanner, and they are what are known as late discovered resources. The exact same applies for web fonts or any base64 encoded assets in your style sheets. Anything that's in the URL brackets in a style sheet is considered a late discovered resource. Browsers will only download a background image if it knows the page needs it. So it needs knowledge of both the HTML and the CSS. It's the same with web fonts. A browser will not request a web font until it encounters the DOM node that actually needs it. This is a sensible defensive measure. You might have a style sheet with 50 @font face rules in it. But if your homepage only uses one of those font face rules, you don't want to download the other 49. So what the browser does is to save resources, save bandwidth. It will wait until it knows what fonts the page needs before it starts downloading them. The problem with that is the browser doesn't know what font or background it needs until it's about to render the DOM node that needs it. So a lot of people, when they try and speed up background images or web fonts, is they focus on CSS performance. How do I get my CSS faster? And what they might do is they might embed the CSS in the HTML, and they're surprised when it doesn't get any faster at all. The problem is CSS doesn't download images or web fonts. The render tree does, and the render tree is the combination of the DOM and the CSS OM transposed onto each other. It's basically only once the browser has full knowledge of the CSS and the HTML of the page, it'll begin requesting things. So the reason these resources, background images, are slow is because they aren't requested until the browser is ready to paint the DOM node that needs it, which is way too late. It's not until the browser needs to put that div or that header or that whatever it is on the page that it will request the image. That is way too late. However, a lot of websites do have background images as their largest contentful paint. The good news is it's really easy to polyfill or hack or work around this to get back to being fast. So, not all candidates are born equal. Your choice of element will impact how fast or slow you can be. Where possible, text-based paints are going to be fastest. After that, I would recommend aiming for image-based LCPs where possible. All right, next I want to talk about common mistakes, things that I see developers do quite often that, I don't know, they're sort of heartbreaking. They're really simple things to avoid. So common mistakes, the first one doesn't even break my heart anymore, it just annoys me. Don't lazy load your LCP. If you want to get an image onto the browser really quickly, don't put loading equals lazy on it. It's completely counterintuitive. I see this quite a lot. In fact, when you look at the statistics across the entire web, there is no way anyone behind row 1 can read that. If you look at the entire web, about 10% of LCPs are natively lazy loaded. A further 5 to 6% of largest contentful paint elements are lazy loaded with JavaScript, which is even slower. So I see this really frequently. People are told, oh yeah, lazy loading your images makes your website faster. And yeah, it makes your website faster by making your images slower. So just don't lazy load your largest contentful image. The syntax for it, the native lazy loading, really, really simple. Loading equals lazy. One thing that a lot of well-meaning developers ask me is, can't we just put loading equals lazy on all of our images, and the browser will decide what's best to do? Because if you're on a slow connection, the browser is more likely to aggressively lazy load your images. Also, the browser uses intersection observer to work out, is the image approaching the viewport? The browser knows a lot of information about the current page and your effective connection type. So can't you just put loading equals lazy on every image, and the browser will decide that, oh, well, this image is actually above the fold, so I won't lazy load this one. That's a really sensible line of thinking. That's a genuinely, I think, a very smart question. But the problem is this, and it's, again, a very elegant bit of design. By definition, or on purpose, loading equals lazy hides the image from the preload scanner. which I think is a really sensible optimization. If we've told the browser this image isn't important, let's not fetch it too eagerly. The exact same demo, just putting loading equals lazy on it, brings us straight back to a pattern that resembles image in SVG or background image. So loading equals lazy will hide the image from the preload scanner, basically sends you back to IE7. So don't lazy load your above the fold images. This is very low fidelity, but one thing I do when I'm working with a new client is I use a browser extension to add a custom style sheet. I put that in my custom style sheet, and I just bum around their site looking for any image above the fold that turns red. Any image with a red border above the fold was lazy loaded and probably shouldn't have been. So if we look at The Economist, for example, their CMS was adding loading equals lazy to their any image component they put in the page. Very low fidelity, but I just click around the site with a coffee. I'm like, all right, okay, that one, that one. The next one, and this is pretty controversial at the moment, but don't build your LCP with JavaScript. It doesn't really matter whether that's lazy loading it with JavaScript or whether that's fully client rendering a site. Don't put any core content behind or in JavaScript. JavaScript is the fastest way to build a slow website. That is really controversial, isn't it? I was working with a company called iPlayer back in the UK. They're like British Netflix, and we were optimizing their site. And the video playback page, the actual episode page, their LCP was really bad. The entire site is server rendered, except the video player image for some reason. The video player itself is full JavaScript. That needs to run on the client. But the actual just holding image, there is no video on this page. That is just an image that we're looking at. But for some reason, they decided the only part of the site they would client render was this image component. And that was their largest contentful paint. So what you can see now is that even if the JavaScript itself was really, really, really fast, we've got to download an HTML page, which then has to download app.js, which ironically they were deferring and loading late. Then that has to run. Then it has to hydrate the virtual DOM with an image tag, which then has a source put on it, which then requests the image. It's not that the JavaScript itself is slow. It's that we're adding extra steps on this path, which ought to be as short as possible. Once we moved it to HTML, the browser discovered the image way, way sooner. There are other optimizations we can still make, like the fact that we had to go to a different domain to find this image. That was a big misfire, and that needs to be refactored as well. But we started making a dent in this quite quickly, and we can see the day that we deployed this change. Hopefully you can see it. It took the developers about 90 minutes to just server render this component as well as everything else and get it deployed. Really small change, made a huge difference. In fact, we got a 43% improvement in LCP. Coming back to the next thing, coming back to the last thing, don't host off-site. The best example I have of this is me messing this up about 2 months ago. Always self-host critical assets. So whether that's Bootstrap or jQuery, or don't use unpackaged to fetch anything like a third-party library. Images, if it's your largest contentful paint, don't use third-party infrastructure to host it. The best example of this is, like I said, it's me. I use Cloudinary to auto-magically optimize my images sort of on the fly, and you just pass a URL like this. I accidentally moved my LCP element over onto Cloudinary, and I shouldn't have done. And you can see it in this chart here. What you'll find interesting is I went from around 2.1 second LCP to 3.5 seconds, so I went way over that 2.5 second budget, all because of nudging this image onto a different domain. What is particularly interesting about this, and not really a great advert for Cloudinary or services like it, yes, Cloudinary did manage to make the image 1.5 times smaller, but it took 2.6 seconds longer to fetch it, all because it lived on a different domain which I had to open a connection to. What I actually did is I right-click Save Image As, and I took the Cloudinary optimized version, saved it onto my machine, and just self-hosted the optimization they made for me, so I got the best of both worlds. Don't usurp your LCP. This is such a shitty slide because I was trying to find the correct word, and usurp was the only real word that seemed to make sense, but it's such an old, archaic phrase. Usurp means to undermine or overthrow, or one of these synonyms was dethrone. Don't dethrone your LCP. This one really upsets me because this almost always is not the developer's fault. When you're working locally, you probably don't have, you almost definitely don't have cookie banners Or those annoying modals that say, hey, sign up to our newsletter. And it's like, I just got here, I don't want your newsletter. You don't have third parties, you don't have analytics, you don't have all this crap running on localhost. The site goes live, and the marketing teams put all this stuff on the site, and then developers get told off because the site is slow, which is criminal. Criminal. I had a really interesting scenario with a client early this year. Just see if you can see what's happening. See if you can tell what happened. On the left is before. On the right is after. And the middle is just a visual diff of day 1 to day 2. You'll notice that LCP got 54% worse from day 1 to day 2. OK. What was that? 2 images? No, that's a good guess. Right, what happened is their CMS is pretty intelligent, and it didn't do any redirects. The interesting thing here, there wasn't a redirect. It all existed at the same URL. On the left, it says Cannondale full suspension mountain bikes. And if you can see, if you're lucky enough to be in the very first row, it says product 1. They had 1 left in stock. They sold it, so they had 0 left in stock. So on day 2, it just said full suspension mountain bikes. Didn't say Cannondale anymore. The H1 got a lot smaller. So what happened is, on day 1, we'll see that the cookie banner was 44.5 thousand square pixels. The H1 was only just bigger at 46,000 square pixels. So on day 1, the fast H1 was the biggest element on the page. The cookie banner arrives a few seconds later, so it's a late-loaded bit of content. Also, none of the developers see the cookie banner, because they don't need it on localhost. They had no idea this had happened. On day 2, the H1 dropped to just 33,000 square pixels, whereas the cookie banner stayed at 44.5 thousand square pixels. The cookie banner became the largest bit of content. No developer was going to spot this, because they don't have the cookie banner on their site. Also, the other problem is cookie banners are usually late-loaded. They're loaded with JavaScript on the client, whereas the HTML, the H1 is right there in the HTML payload. So my advice here is test in live, obviously. Get monitoring set up if you can. And if you do have cookie banners, make sure they aren't bigger than anything else on screen. Try and design them or redesign them in such a way that they're very subtle and that they load as quickly as possible. I found that a really interesting case study because that's not a developer's fault at all, and we were lucky that my monitoring captured this. I see this all the time, and that one does break my heart because the developers did a good job. And the CMS is really intelligent to sort of do that without redirecting them. It just says, well, you can't view that anymore. I'll show you the next best thing. It was this like imperfect storm, which meant their LCP got a lot worse. All right, okay, so that's mistakes. That's a bit pessimistic. Let's look forward. Let's look at some stretch goals. What I want to go through next is a few relatively new APIs, very simple to use APIs, that will basically take us ahead of the curve. So rather than just avoiding making mistakes, let's be a bit more visionary and let's look at some stretch goals. The first one, the one you're most likely to have seen and probably implemented, is resource hints. Resource hints are really, well, they're not that new anymore, really powerful. But with anything powerful, I guess, don't overuse it. I'm going to say that before I even show you a snippet of code. Don't overuse any of the things I'm about to show you next. So these are the ones you're probably most familiar with. There can be a bit of an anti-pattern if you do use too many of them. But the one I want to talk to you about is preload. And I guess, just show of hands, who's used preload before? I'd say about a third of us. That's pretty cool. So preload, it usually lives in the head tags. And what preload does is it is just a declarative fetch or a declarative instruction for a browser to fetch a resource. This is really good for late discovered resources such as background images because the clue is in the name. Preload is great for reintroducing late discovered resources to the preload scanner. Anything that would be hidden from the preload scanner, in our case, that would be background images or image in SVG. Preload's a great way to reintroduce them. I'm already feeling guilty because, again, this next slide has a diagram that probably won't be that readable at the back, but there's a really good example here. I used preload to get around the problem of having a background image as my largest contentful paint. There's some really interesting stuff going on here. Sometimes even the smallest waterfall charts can tell really quite interesting stories. So I use a background image on my site as a largest contentful paint, and that is going to be slow by default. So what I've got here is the top slide is my site before using preload. You can probably maybe see this, but I'll talk through it. So before preload, the background image was requested from the body phase of the document. Whenever you're looking at a waterfall chart in any Chromium-based browser, it's really easy to spot where your head tags are, because Chrome does something very interesting. Chrome loads every web page in two main parts. First thing it does is it swarms your head tags. Your head tags are vital. They're really important. So Chrome downloads all your head tags first, all your items in your head tags first. Then what it'll do is it'll download one, maybe two lower priority in-body resources. Then it'll open the floodgates and download the rest of the body tags. So what you can see in the top is we've got a bit of green here. That's a style sheet. That style sheet is 100% definitely coming out of the head tags. Fourth item is this purple. And that purple is my largest contentful paint image. So the purple is the fourth item to be requested. And is it the fourth? Yeah. The fourth item to be requested, and it's getting fetched from the body phase of the document. And also, what you'll see is it takes 932 milliseconds to download, because this is something really interesting. Because this is an image coming from the body tags, Chrome's downloading loads of other stuff at the same time. There's only a finite amount of bandwidth that a browser ever has available to it, so it has to share some of that bandwidth with scripts or documents. If you look at a waterfall chart, you'll see a dark purple and then light purple. Dark is when the server is actually sending bytes to the client. What you'll see here is that, okay, it's sending some image bytes, but then here it's sending HTML bytes, and then there it's sending JavaScript bytes. The bandwidth is getting shared across many different files here. As soon as we put a preload in the head tags, we'll find that the file is now requested third instead of fourth. It's requested alongside the CSS rather than after it, so it's now getting requested from the head part of the document. But also, because it's coming from the head tags, the server and the browser have decided to donate more bandwidth to the image than anything else. So the same image, it weighs the exact same. It's not been optimized. The image is still the same file size. Downloads in 445 milliseconds. Over twice as fast for the exact same amount of data, because the browser and the server decide that we'll give all of our bandwidth to this image rather than sharing it among different resources. So this is quite a powerful tool if you're using background images for your LCP. However, there is a bit of a bug in Chrome. I won't explain it in this talk, but if you are going to use preload, please at least go and read this article first. There are problems with preloading Chrome. It can steal too much bandwidth. The browser and server can give bandwidth to the image that should have gone to, say, a CSS file. I've worked with sites before, or with clients before. We preloaded their image, and the actual first paint got slower because the image downloaded before the CSS. Okay, priority hints. This is, again, really, really simple, and this is one of my favorite things in the world right now. Has anybody used priority hints yet? Oh, about two of us, right, we'll get beers later. Priority hints, again, a very, very simple specification. The syntax looks like this. It's literally fetch priority equals, in our case, high. This normally goes in the body. Not always, but normally goes in the body tag. It's great for in-page resources. So we've got fetch priority low or auto. We're not interested in those right now. Basically, what fetch priority does is it reduces the amount of time the browser spends queuing resources. So what it will do is it will encourage the browser to fetch the file as soon as it discovers it. Normally, what browsers do is they'll discover a load of files, and then it'll try and make a shopping list, and it will actually request them at a certain time. It will schedule them and queue them. Fetch priority gets rid of that queuing time. So what we need to do really is just understand briefly what priorities are. Every file that gets downloaded by a web browser, in every web browser, it's not unique to Chrome, every file has a priority, and that is basically how important is this file to the page. By default, all images are given low priority until the browser knows they're in the viewport, at which point it can change the priority to high. But again, the browser doesn't know the image is in the viewport until it's ready to render the image. That's way too late. You can actually see this happening. When you look at web page test, you'll see that the image's initial priority is low, but then when the browser realized it was in viewport, it changed it to high. This happens way too late. I'm about to show you a quick screen recording. I want you to keep an eye on the small little red, it's pink, but it looks red on this screen. So a little red, pink circle on the next screen. I just want you to keep an eye on the middle of that circle. So this is the LCP image. And it said low for a long time. Then it changed to high. It changed to high once the browser realized it was in viewport. If I just pull this out into a static screenshot, you'll just have to trust me. The browser queued that image for 2.16 seconds. The browser knew the image existed, but waited 2.16 seconds before requesting it. If we've only got a 2.5 second budget to play with, we don't want to lose 2.16 of those seconds to the browser kind of twiddling its thumbs. That led, in this case, to a large contentful paint at 14 seconds, 13.8 seconds, completely unacceptable. So what I did for this client is I just went into their sort of hero component, and I just added fetch priority equals high. Just a brief interlude, a brief tip. If you are freelance or you work for yourself, never tell your clients what you actually did for them, because I can't submit an invoice that says, I did fetch priority high to an image, and now you owe me €5,000. Always tell them the outcome of what you did for them. So I did fetch priority high to this image. Keep an eye on that same red circle. Immediate. As soon as the browser knew this image existed, it went off and got it, because we told it this is a very important file. Again, if we pull this out into a static screenshot, we will see that queuing time here was now 0.85 milliseconds. It's gone from 2.16 to 0.85. Another tip for trying to impress clients is I'm not going to tell them it went from 2.16 to 0.85 milliseconds. I'm going to tell them it was over 2,000 times faster. Technically, it was over 2,000 times faster. That led to an LCP event at 4.9 seconds, so still not good enough. Still twice over budget. That's a huge dent, right? A nearly 9-second saving for the sake of one attribute. Fetch priority high is really powerful in the same way preload is powerful. Use them sparingly, don't use too many on a given page. So these are the key takeaway figures. We saved almost 100% of our queuing time, and we gained an extra 9 seconds for that LCP. Right, last tip, I promise I've gone way over time. Image decoding, this is the it's the newest, and therefore the least utilized and worst documented API I want to talk about. The reason image decoding is the the least used, is because all the documentation around it doesn't really tell you a good use case. It just explains, well, I'll show you what I mean. Image decoding is said to be synchronous if it prevents presentation of other content until it's finished. This is from the spec. Now, the word prevents immediately makes this sound like a bad idea. I don't want to prevent anything, so you would avoid using this, right? If we reframe the problem, well, maybe we do want to prevent other content. If we need to optimize for image display, rendering images quickly, maybe we do want to prevent other content. So I did a little test. So image decoding, again, really simple new API. It tells the browser how to deal with image decode tasks, and our options are sync, async, or auto. Auto is pointless. You wouldn't ever need to use auto. It's redundant. The first thing I did is I ran a test in which decoding was async, and now this is going to be the worst of all the diagrams. This is definitely the smallest one. If I force the browser to asynchronously decode an image, something very interesting happens. What you can hopefully maybe see, you definitely can't. The very first frame, the first visual change, shows a tiny thin sliver of image decoding. The second frame shows the exact same visual appearance. A frame means that the browser painted a visual change, but none of that was above the fold, because what I've done is I've put 1,000 paragraphs underneath this image. So what the browser did is it did something and painted an update to screen, but that update was useless because it wasn't above the fold. A pair of eyes never saw it. The third frame shows the fully completed image. What happened in between is we got a style recalc and layout task. Because we told the browser you can decode this image asynchronously, the browser was allowed to go and do other things. And what it chose to do is go and work out the size and position and the layout of some of those 999 remaining paragraphs that were off screen. What that means is we had an overall decode time of 700 milliseconds. It took 700 milliseconds from the first decode event to the last. If you've got a 2.5 second budget to play with, losing 0.7 seconds to simply decoding the image is way too much. So I simply swapped this out and put decoding equals sync on the exact same image, and we got a way healthier graph. What we saw is the very first frame shows a beginning of an image decode. The second frame shows a completed image decode. There is no third frame. And all we did is image decode tasks throughout. The reason I paused there is because I looked at my next slide. I was like, holy shit, that looks like a frog. I saw, sorry, I just had a moment in front of you all there. I was like, oh my God, it looks like a frog. That's awful. So yeah, we did only image decode tasks in the middle. We didn't do anything else. We dedicated 100% of the thread to decoding images, not doing anything else, which led to an overall decode time of 320 milliseconds, which is over 2 times faster. So a pattern that I'm encouraging clients to experiment with, and when I say experiment, I mean it will probably work, but please test it before you put it live, is just adding fetch priority high and decoding equals sync to your LCP image. Encourage a fast fetch, encourage a fast decode. We could potentially buy seconds here. On the flip side is every time you implement loading equals lazy, maybe add decoding async as well. Interestingly, because loading equals lazy hides the image from the preload scanner, you don't need to put fetch priority low, because fetch priority low is implied by loading equals lazy. Okay, sorry, let's try and wrap that up, because that was a lot of stuff. So trying to put it all together, what I would advise is, if you need to optimize LCP, which statistically most websites do, it's the final metric, so solve everything beforehand. If you've got time to first byte problems, go and look there. Choose the best candidate. Text is the best, image is the second best. The reason image is the second best is because you can't add decoding sync to a poster image, right? So image, the image tag, has loads of additional things we could use, such as fetch priority, such as decoding. Expose the LCP candidate early. Make sure your LCP image is defined in HTML. Make sure there is no JavaScript in the way of the browser discovering that image. Don't work against yourselves. Don't make silly mistakes. Don't let your marketing team make silly mistakes on your behalf. Help the browser in situations where we know more than the browser. Use things like decoding, use things like fetch priority. And finally, test everything. You can go too far with these techniques. You can flood the early sort of bit of the network with too many image requests and slow the rest of the page down. So please, please, please test everything. With that said, I've gone way over time. I just want to say thank you for your patience and thank you for listening. Questions?
Thank you. Thank you, Harry. Is there any questions?
Thank you for everything. It was very useful. I think that you were speaking about images and lazy loading. What if you have a slider and then you go to page speed test and it tells you to lazy load the rest of the images? What would you do?
If you can interject in the component and make sure you've got loading equals lazy on every subsequent image, I would 100% do that.
That's okay.
Yeah, 100%. If it's an off-screen image in a slider, lazy load second, third, fourth image, also decoding async on those, and that's definitely what I would do.
Okay, so is it that, or like some sliders have option, so all those other slides, to add a tag, and then JavaScript switch when slider comes. So what's the better option? If you understand.
So some sliders will use JavaScript to fetch the next image.
When it's
yeah.
They actually just switch. You know, you don't have
the source
background image, but they're gonna swap.
Yeah, because it's a slider, no one's using it anyway, so it doesn't matter. The JavaScript option in that case isn't too bad. The only problem is, if anyone's old enough to remember Dreamweaver hover states for images, and the JavaScript would run when you hovered it, and you've got all the latency, and so it could be a jarring experience if the image is only put into the virtual DOM or the DOM when someone clicks. So you get into a complexity of, do we prefetch the images? My preference would be build it all in HTML, use loading equals lazy on the second, third, fourth image, if possible. An interesting implication here is a lot of CMSs, and WordPress used to do this, it was binary. You either lazy load all your images or don't lazy load any at all. So a lot of WordPress sites got a lot slower because their only option was to lazy load every image on the page. They fixed it, but some other plugins haven't, whatever. What I normally recommend is if your options are lazy load every image on a site or don't lazy load any images at all, my advice is actually don't lazy load at all. I would make sure the biggest image is always the fastest, and I would choose not to lazy load anything in that case. In the case of the slider, I think using JavaScript wouldn't be the worst thing in the world because it is late content and it's off screen. Ideally, if you can interject that component and identify the first image tag, put fetch priority high on that, and then loading lazy on the others.
Thank you.
Cool.
Any other questions?
And the
Way
last-
over there.
and
Can we
the
do
la-
this?
And the last one, I
Can we
guess.
coordinate so we ask the furthest away questions? So Stanislav has to run around with the microphone.
Yeah, you can ask the question and maybe Harry can repeat Milana, I guess.
Hi, Harry.
Hey.
It's good to see you again in Novi Sad. And if the weather is your doing, then please leave soon. Just kidding. So my question is, compared to other two core vitals, web vitals, what is the percentage of this first contentful paint being the most problematic on websites, or how performance is improved in general? What is the percentage of improving this one?
For first contentful paint.
Yeah.
Okay, this is a really good question to which I've got a bit of a philosophical answer. First contentful paint isn't measured as a core web vital, so as we know, if we're only optimizing for SEO, we don't need to worry about first contentful paint. If you've got a slow first contentful, you're almost guaranteed to have a slow largest contentful, so optimizing both would be sensible. As far as percentages, I'm not sure how important it is or how many sites are failing, but I did have an incident with a client recently. We put fetch priority high on their LCP image. What that did is it made LCP 1.5 seconds faster, which is huge, but it made FCP 0.5 seconds slower. That's because bandwidth that could have gone to a style sheet went to an image tag instead. And we still haven't decided what the correct answer is. Are we willing to sacrifice a half-second slower first contentful in exchange for a 1.5 second faster largest contentful? I'm actually of the opinion that I would rather have a faster first contentful, because at least we can show the user something. The other half, well, the other parts of the team were like, well, no, if we're interested in SEO, then LCP is the only thing we care about. So that was a long answer to actually not even the question you asked, I'm afraid. Percentage terms, I don't know how badly that's affecting things. It's not tracked as a core web vital, so the data isn't available. But my general advice is, if you improve fastest contentful, you will improve largest contentful anyway. So sort of tackling both is going to be wise. And then there's the philosophical debate of, are we optimizing just for SEO, or are we optimizing for the user experience? And I didn't really get an answer to that myself either.